Hello friends, welcome to our channel Knowledge Amplifier. Today we are back with another very interesting topic related to real-time stream processing using Apache Kafka. And that is, we are going to build a data pipeline where we will publish the sensor data captured using our mobile phone to a Kafka cluster using REST API. Okay, so this particular diagram is showing the overall flow. That is, we will be having our sensor, which is basically available in the mobile phone, smartphone. And from that smartphone, we will consume particular measurement, like for example, temperature or location or acceleration, etc. And then we will publish that particular data to our Kafka cluster using a REST API. That API we will be building using API gateway. And once our sensor will hit that particular API will basically send that event to AWS Lambda. They are using Python code, using Kafka Python module. We will publish those events in Apache Kafka. Okay, right? So without any further delay, let us try to understand how using simple mobile phone we can capture the smartphone data, right? So for that, we are going to use one app which you can easily install for Android or iOS system. That app name is Sensor Logger. Okay, the particular app installation link I'll be providing in the description box also. You can check from there. Okay. So once you install that app in your mobile phone and open it, it will look like this way. So it basically logs several measurements from different sensors which are available in our mobile phone, like accelerometer, gravity, gyroscope, orientation, magnetometer is there. If you scroll, you will get more, like for example, if you want to capture the images using camera, you can do that. If you want to capture the audio using microphone, you can do that. If you want to capture the ambient brightness, surrounding brightness around your smartphone, then you can use this particular ambient brightness measurement sensor. Okay. To check the battery level, you can use this one. To check the screen brightness, you can use this one. Like that, different options are there. Okay, right? So today in this video, we are going to consume the ambient brightness or surrounding brightness around our mobile phone, and that we are going to publish in our Kafka system. Okay. So to capture the sensor data, what we need to do, we need to make this toggle true. So this particular picture is showing that one only because we want to capture the ambient light. So we have basically made this particular toggle true. If you click on this particular I button, it will show you the sensor data as a graphical format within the app itself. Okay. So we are not going to use that. We are going to publish the captured sensor data in Kafka cluster. Okay. Now here the same thing is shown, that this particular toggle we have enabled, and if you click on this particular I button, then this page will open where it will show you the surrounding light samples. Okay, this y-axis is basically showing surrounding brightness and this is basically samples. Here in the description you can read that it measures the relative ambient brightness using the ambient light sensor which is available in our smartphone. Okay, sample. This is non-configurable. If you are using paid version, then might be it is configurable, but we no need to check much on that because we want to feel the real-time activity. We want to get the idea how to publish sensor data. So sampling is fine as per default property, and the unit is lux. Okay, to measure the ambient brightness. Okay, right? Now coming to the next part, that whatever data it will be capturing, that in real time, this particular app need to send to Kafka using REST API. So how to configure that API, what we are going to build using API gateway, that we should understand. So for that, what you can do, here in the page, you will see a icon of settings. If you click on that, the settings page will open and that will be like this. And here you will be seeing an option, HTTP data push. Okay. So here in the push URL, you can provide that particular API gateway URL where the data will be pushed with certain interval. Okay. So what the particular sensor will do, it will batch the records with 1 second interval and it will flush all together as JSON array to our REST API once 1 second is over. That also is written here that it posts to HTTP server during a recording session. Data is batched into a JSON array over this specific time period and sent to specified URL. Okay. So what we have to do, we have to enable this particular toggle to make sure the sensor data is pushed to this particular URL, and we need to configure this particular URL properly. Okay, right? So that particular one is shown here. that if you enable this one, then the toggle will be on, and then here you need to update the URL. Okay. Now once you update the URL and go back to this particular page, that is logger page, here if you see that in this particular place nothing is displayed, right? But once you complete this particular configuration in the settings, here it will show you with a note point that HTTP data push enabled for this particular sensor data. Okay, right? So I hope you understood this. The configuration I have already done in my mobile phone, and I have taken screenshot for each step so that you can basically configure in your mobile phone very easily just following this particular video, right? So I hope up to this you found it very simple. Now the question comes, when our sensor data, this app will start pushing to the HTTP endpoint once you click this particular start recording button. Okay. As soon as you click on start recording, this app will capture the ambient brightness, and with 1 second interval, it will push that to this particular URL. Okay, as simple as that. Now, obviously, if you check our architecture, so we understood how to configure the app such that it will publish the ambient brightness to the API. Now, the next point comes that Lambda code, which will publish the data to Kafka, right? So, let's check that. So, this is our Lambda code. It is a very simple Python code. We are importing JSON, time.sleep. We are importing JSON.dumps is required sometime to convert the string data to JSON data. And here we are importing Kafka producer from Kafka Python module so that we can publish the messages which are coming via REST API to Kafka cluster. Okay. Import JSON I have taken 2 times, so this is not required. Here you can configure the topic name in which Kafka topic you want to publish the data. Here you can configure the producer, and here you can mention the Bootstrap server URL for your Kafka cluster. And here I am keeping a very simple JSON serializer. Okay. And this is our Lambda code, which will be triggered as soon as API gateway will get some data from the sensor. And as I already told you that our app will batch all the records for 1 second interval, and then all together that 1 second batch data as JSON array, it will be publishing. Okay. So here, how the JSON looks like, let's observe that. Then we can understand this particular code easily. Okay. So here I have already taken a sample for our JSON data, how from app it is coming. So if you see, this is a complete JSON set. I will be sharing this particular JSON set also in the description box so that you can refer this to explore more. So if you see here, we are having a key called body, and that body content is basically string. So here what I did, from the event, first I extracted body, and from that string data, we need to convert that to dictionary, right? So I have used JSON.loads. Okay. So that way this particular part will be converted to a dictionary. And then here you can see a key called payload. And that payload is basically a JSON array where the array is starting here and it is ending here, right? So here I have taken only the value part corresponding to the key payload. So obviously payload part will be nothing but an array. So we are iterating in that array. And then here what I am doing, I am extracting the value key. From value key, I am extracting the ambient brightness, which is coming in lux unit. So if you see here, that payload is the main key. Within that payload, here individual JSON elements are there within that array. And here value is the key. Within value, there is a lux key, which is basically showing the ambient brightness. Okay. And then here we are having a key called time also, which is showing the Unix timestamp when the event is captured, right? So based on that only, I am capturing the light illumination in our surrounding and the capture time, and that we are publishing using producer.send method in fire and forget manner to our Kafka cluster. Okay. Once the for loop is over, we are flushing all the data to make sure no data is remaining in the buffer. And then we are returning that hello from Lambda. You can return some better message also, not a problem. So this is our basic Lambda code. I hope you understood this. Now without any further delay, let's configure all these things. Let's configure our Lambda code. Let's create the Lambda layer, because here the Kafka Python by default is not available in our Lambda execution environment. So we need to create a layer. We will create API gateway which will trigger our Lambda, and then we will go to our mobile sensor app. Okay. So here I have noted all these steps in this notepad. Let's go to the first step. As a step 1, we are going to create the Lambda layer. Already the Kafka Python layer for Lambda we have created in our previous video, which I already uploaded in GitHub. So I am just going to download from there. Okay. So here I am downloading that Kafka Python layer, and then here this is our Lambda code. So let's complete the Lambda layer creation. So I can open Lambda in a new tab. and here I can open S3 also, because this particular file we are going to upload in S3. Here in a bucket, let me upload that. So it is uploaded. I can click on that, and then here I can go to layers, create layer, Kafka Python sensor demo. Okay, and the object URL I can copy, and then here I can select the option and paste that object URL. Runtime is Python 3.8 for this one, and we can create the layer. Okay, here the layer got created. Now here I will open Lambda in a new tab. I'll go to function, create function, some random name I have given, and the runtime I am choosing as Python 3.8, and I can create the function. Now here I will copy the Lambda code what just now we discussed, and then here we will paste in the Lambda environment. Okay. So here I can paste this one, and I can click on deploy. So it is updated. Click on layer, add a layer. I will go to my layer ERN, I will be copying, and then here specify the ERN. I will paste this particular ERN. Click on verify. It is verified, and I will add this one. Okay. So with this, our Lambda is ready pretty much. Now here I will go to AWS Management Console, and I'll be creating a API very quickly. So because this is a POC, I am going to create one HTTP API. API name demo sensor Kafka. I will click on next, create. So here it is created. I will go to routes. Now I need to create a resource path, because the app will post the data whatever captured to this API, and here I can give the resource path as publish to Kafka. Okay, I'll create this one, and this post API integration we will be creating with our Lambda. So only one Lambda function is there. I will choose that, and I will create that one. Okay. So here it is pretty much done. If I go to Lambda, here the trigger should be added. Let me refresh that. And here see, our API gateway Lambda trigger is added successfully. Layer is also done. Now quickly I will create one Kafka cluster in our EC2 machine. So here I will click on instance, launch instance, Kafka cluster demo. Okay, Amazon messaging image, we can choose this one, and then here key pair, I can choose one existing key pair, and then here we can launch the instance, keeping all other properties as default. Okay, so it is done. Let's go to that. Here it is in pending state, that's fine. So I will go to security, and I will add all traffic as of now as part of inbound rule. Later when we go to production, that time we can make these things more secured. So see, our cluster is now running. I will go to that, and I will copy the public IPv4. I will go to putty. I'll paste the host name. I will choose the key pair. I will open this. Yes, and login as EC2 user. I'll make sure no timeout is happening. So I will change the connection timeout to 10 seconds. Apply that, and then here first quickly we will install Kafka, and then once it is done, we will unzip that. All the codes I'll be providing in the description box or in the comment section. So here to work with Kafka we need Java. Java don't come by default, so we are installing Java also. Okay, it is done. Now here what we will do, we will go to this particular directory, and then here we will start the zookeeper. Let zookeeper start. By that time we need to start the Kafka server also, and for that we need to configure the advertise listener to public IP of EC2, right? So we'll do that quickly. So I'll copy the public IPv4, and then here I will go to new site, hostname I'll paste that, user ID by default for Linux machine it is EC2 user. I will choose the key pair file for authentication, and then here what we'll do, we will go to Kafka config, Kafka. Within that here we are having config, and here within that we are having server properties file. We'll open that file, and one property we need to change. If you check the documentation already we discussed, that is advertise listener, right? Just you can search with that. Okay, it is not found, it is showing because it is in small letter. Here your hostname we need to pass the EC2 public IP so that the broker is accessible from public IP. Okay, so save this one. So here it is completed. Let me open the file again and check whether it is updated or not. Yes, it is done. Now here what we'll do, we will basically duplicate this particular session, and in this particular place we will launch our Kafka broker. Okay, to launch the Kafka broker we need to execute first the export command, and then we will go to this directory, and then here we will start our Kafka server. All these things I discussed several times in my previous video, so I am going a little bit fast here. So here you will notice that the Kafka broker is running in our public IP. Okay, I will duplicate the session again, and here I will enter with EC2 user. Now as a next step we need to create the topic. For topic here we need to configure the EC2 public IP. So here I will copy that, and here EC2 IP I have copied. Even for starting our console consumer we need that EC2 public IP, so I have taken there also. So let's create the topic first. So here if you see the topic name, we are providing sensor data consumer. In our Lambda code also if you observe that the topic name is sensor data consumer, right? So here our Lambda will be publishing the data. So here let's do that quickly. So here the topic got created, and now as a next step we can start our console consumer. Okay, so as of now the topic has no data, so console consumer will display nothing. Let me update this particular broker URL to our Lambda code also. Make sure you are not doing this mistake, otherwise Lambda messages will not be published successfully. Okay, so here let it update. By that time what I will do, I will copy the API URL to my app. Okay, so here I will go to API. This is our invoke URL. I will copy that, maybe save it somewhere in my notepad. Okay, so this is our main path, main URL. Along with that we need to provide the resource path. So the resource path is published to Kafka. So this one now we need to configure in our app. Where we need to configure, if you see in the HTTP data push, in the push URL we need to configure that. So let me quickly do that. So I have configured this particular URL in my app, and now here this particular toggle is also enabled, and I have enabled the ambient light sensor capture toggle also. Now what should happen, that as soon as I will click on start recording, the ambient brightness in lux unit, this app will start publishing to this particular API, and from API it will go to Kafka cluster. Okay, so we will see that. So we will intentionally try to change the brightness. I will start the camera also so that you can see what activity I am doing, and based on that here you will observe in consumer the sensor data, the lux data, whatever is capturing light brightness, that will be going up or down. Okay, so for that what I will do, I will open my IP camera. So here my IP cam page is open, and now if I click on browser video renderer, then the video will start getting displayed what I will capture from one of my mobile phone, and then it will be displaying here so that you can see the brightness. Okay, so let me start browser. So if you see here that I hope you can observe the video part. Now here in this particular mobile phone, here I have enabled the ambient brightness capturer, and here if I click on settings, then here you will observe that in HTTP data push I have configured the push URL and enable HTTP push also. That toggle also I have enabled. Okay, now I will go back and I will start recording. As soon as I will start recording, you will observe in the console consumer the messages will start flowing. Okay, so let me just quickly open the consumer somewhere here. Okay, right, so you can observe this particular consumer part, right? So here what I will do, I will start the recording. So see, recording is started. As of now we are running with constant, almost constant brightness. Intentionally we are not changing the brightness. So here if you see that the light illumination is coming 91 to some almost constant value with respect to capture time. Okay, now what I will do, using my pen tab, I will basically try to make some shadow, and I will ensure that the ambient brightness is decreased, and then you observe this particular sensor data, you will see it will start drastically decreasing. Okay, let me just unlock this once. So here I have unlocked, so it is almost constant. Now here what I will do, using pen tab I will guard this. So as soon as I made some guard, you observe that the sensor value now drastically decreased to 26, 25, 23 like that. Okay, now if I completely guard it, here you will see now here the value light illumination is now reduced to 0, because the pen tab is completely cutting down the light illumination to our sensor. Okay, so as soon as I will remove this particular one, here you will see that the values will again go back to the 93, 94 like that data point. Although our mobile screen is off, but in the back end the app is consuming the messages using that ambient sensor, and it is publishing to that API. Okay, I can unlock this, and then here you will see that almost same value it is showing. If I just bring this particular mobile phone little bit close to my light or bulb, here you will see that the light illumination is increasing. Okay, because here in this particular place I am having my light on. So here you can see that because we are moving towards light or bulb, so in this screen here the ambient light illumination is also increasing. Like that, in real time, whenever we are decreasing the brightness, here you will observe the light illumination automatically decreasing. Like that, in real time, the sensor data from mobile phone is getting captured. Okay, so now here I can stop the recording, and that way here our real-time framework will stop publishing the data to our Kafka cluster. Okay, right? I hope you understood this. This is all for this video. So all I wanted to cover is how you can basically consume the smartphone data only in real time and do some awesome experiment with some AWS services. If you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.